Hey guys. You're going to have a quiz tomorrow. Alright, and this is to get you ready. It should be an easy quiz and help bring up your grade if you need it from the way more difficult Chapter 3 Quest 2. Okay, so you're being asked on the first several problems to determine if data presented in multiple ways, whether it's a graph or a list of coordinate points or a table or whatever, tell me whether it's a function or not. If it's a graph, then we're looking to see if the graph passes the vertical line test. Well, my very first graph, if I draw a vertical line, it passes through the entire graph. So this would be no. And drawing the vertical line shows why. Number 2, this is a function because no matter where I look at vertical lines, I would only ever be touching one dot at a time. Number 3 is also a yes because even though this is a curve, okay, every vertical line only touches the graph in one spot. Okay, now we're going to look at data presented to us as coordinate pairs. In coordinate pairs, all we're looking at is the x values. Don't even look at the y values. Okay? 0, 2, 4, and 6. They are all different, so this is a function. Zero, 3, 5, 5. Okay, wait a second. That 5 and that 5 are duplicates. So that is not a function. I want to point out to you some ways that they're trying to be tricky here. Number 1, this 3 and this 3, that's not considered a duplicate because this 3, the second one that's not highlighted, is a y value. We're not looking at y values, we're only looking at x values. Same thing with 5 and 5 here. Notice I did not highlight the second 5. That's because we don't look at y values. We only look at x values to see if there's any duplicates. Okay. In the next one, it's data presented in charts. Here again, I am only looking at x values. I'm ignoring the y column completely. And the ones with the arrows, what I'm looking for, the problem areas would be if there's 2 arrows coming out of the same number. So that would make this one a no. In number 7, when I look at only the x values, because that's all I look at, I see that each one has only 1 arrow coming out of it. So that would be a yes. Again, there's tricky things on the y side to try to fool you. That -1 has 2 arrows pointing at it. Doesn't matter. We don't even look at that side. Okay, what if the data is presented to us in a chart? Well, we look at the x values, and we're just looking to see if anything is repeated. Alright, 5, 6, 7, 8, and 9. Nope, they are all different. So this is a function. Don't even look at the row of y's, because there could be things in there to trick you. Number 9. I'm only looking at the x values, and oh, I see duplicates. Remember, I expect you, if you answer no, I expect you to circle what the problem was. Okay, next we're going to be evaluating functions. So that means, notice that x became a 7. So we're going to sub in negative 2 times 7 minus 1. Now, a lot of you are going to be tempted to just answer negative 15. And while that's correct, it's not the entire correct answer, because the answer is only negative 15 if and only if x is 7. So you have to put that in. If this were doing if we were doing f of 3, the answer wouldn't be negative 15 anymore. So we have to give a complete answer. F of 7 equals negative 15. Because only f of 7 will be negative 15. G of negative 6. So we're replacing the x with negative 6. Now remember, a negative times a negative would be a positive. And you also have to follow order of operations. Multiplication comes before subtraction. So G of negative 6 equals 16. But I had a lot of students telling me 12 or negative 12. Some were telling me 8. Okay, you're either making sign errors or order of operation errors. And remember, as much as I wish that you didn't need the calculator to do some of these calculations, don't let those things be the reason you get this wrong. Order of operations is not an 8th grade skill. Evaluating functions is. Use the calculator to get the right answer when you need to. Okay? Next part, we've got some charts to fill in. So remember, you're going to show your work by making a row of work for every value in the table. So there's 5 values in the table. I need 5 rows of work. It says 3x plus 2. Okay, and notice I replaced every x with parentheses, and now I'm going to fill in the numbers. Negative 5, negative 5, negative 3, negative 3, negative 1, negative 1, 1, 1, 3, 3. And then, using whatever tools you need to, your brain, your calculator, both. And 3 times negative 5 is negative 15 plus 2 is negative 13. Negative 9 plus 2 is negative 7. Negative 3 plus 2 is negative 1. 3 plus 2 is 5. And 3 times 3 is 9. 9 plus 2 is 11. Okay? Same thing over here. Such a habit to write that x. This one's kind of tricky because it says negative x. So write negative parentheses for each negative x, plus 7, plus 7, plus 7, plus 7, and plus 7. Okay, so our values are negative 4, negative 2, 5, 6, 10. Now, the first couple are kind of tricky because they both have, there's a negative from the equation itself, and there's a negative in the value. So we have a double negative for the first couple. A negative, negative 4 really means positive 4, and positive 4 plus 7 is 11. Negative, negative 2 means positive 2. Positive 2 plus 7 is 9. Now after that, the 5, 6, and the 10 are not negative. Okay, they are positive numbers. So we're only having this one negative. If this is confusing, guys, remember, type it into the calculator. You can type these in symbol for symbol, negative, parenthesis, negative 2, parenthesis, plus 7. The only thing you have to remember is don't type subtractions for these. Those are negative signs. So you make sure you're typing the negative key. So this one actually is negative 5. We technically don't need the parentheses, but I'm trying to stay consistent. Negative 5 plus 7 would be 2. Negative 6 plus 7 would be 1. And negative 10 plus 7 would be negative 3. Okay. We have a whole number coefficient. We're using 0, 1, and 2. Same idea as what we were just doing, except we're going to take the values that we get in this table and we're going to graph them. So we're plugging in 0, we're plugging in a 1, and we're plugging in a 2. 0 take away 5 would be negative 5. 4 take away 5 would be negative 1. And 8 take away 5 would be 3. So graphing that, 0, negative 5, 1, negative 1, 2, 3. Don't forget to extend the line all the way to the edges. Don't forget to put arrows. Don't forget to write your equation on the line. Then this last part, which a lot of you skip doing, and it's not hard. 5 is an x value. All I'm going to do is extend this chart one more row. But I'm going to skip right from 2 to 5. Because I'm not worried about graphing this. 4 times 5 is 20. Take away 5 is 15. So I got an answer of 15 over here, and the coordinate pair says that it should be 15 as well. So we would say yes. Write a full sentence here, guys. 5, 15. Now, a lot of you want to write the same thing every time, but we're asking the question in different ways. It means the same thing, but just like in social studies or English class when they say use the words from the question in your answer, do that. It says, is the point 515 on the function? Yes, 515 is on the function. Okay, our next row, our next problem, has a fraction in it. And remember, that means we're not going to count 0, 1, 2. We're going to count 0, 2, 4. Now, why did I count by 2's? Because my denominator was a 2. If my denominator was a 5, okay, if it was 2/5 x plus 4, I'd need a bigger graph, but I would count my table by 5, 0, 5, 10. So it's whatever the denominator is. All right, so 1/2 times something plus 4, 1/2 times something plus 4. So 0, 2, and 4 is what I'm plugging in. Half of 0 is still 0, plus 4 is 4. Half of 2 would be 1, plus 4 is 5. Half of 4 would be 2, 2 plus 4 is 6. So 0, 4, 2, 5, and 4, 6. And I'm seeing a pattern, down 1 over 2, down 1 over 2, down 1 over 2. Keep following the pattern. Make dots all the way edge to edge. Okay, there's our graph. Lastly, is 10, 11 a solution? So I'll go over here, make a row, and I'll skip right to 10. Let's see, half of 10 would be 5, and 5 plus 4 is 9. They said it was going to be 11, so no. 10, 11 is not a solution to the function. Use the words from the problem. It's the same mathematical process. We're doing the same thing to find out whether it's yes or no, but practice using the different words. All right.